Okay, so we talked yesterday, we introduced the U substitution. Okay, so U substitution, we use U substitution anytime we can't just straight up use the power rule, right? We can't use the power rule like the one question, number one, that you had on your quiz. That is a power rule question, right? You didn't need anything else. You could have used the power rule, right? Add one to the power, divide by the new power, right? So anytime we can use that, I would suggest using it, unless it's something like this, right? I can use the power rule for this guy here, for 4a, but I have to expand it first, right? I have to expand it. And when I expand it, it takes some time, right? As opposed to just going to U substitution. Okay, so it's just another option, right? In for antiderivatives, for integration, we don't have a quotient rule, product rule, chain rule, right? It's kind of everything is all of three of those are in what we call U substitution. Okay, the steps for U substitution. First rule or first step, can we use a regular power rule? And is it beneficial for us to do that? If it is, do that. Don't go on. If it's not, go on to the next step. Identify what U is. Okay. Once you do that, find the derivative of that. Then solve for dx. Sub U and du back in. Now you can find the antiderivative using the power rule. Sub everything back in, you're done. Okay. So a lot of steps, but each step is very manageable. All right, so let's look at 4C. 4C now. So 4C is our first trig, right? It's a trig function. Okay. So we got to find the antiderivative of 3x. Okay, so 3x, sometimes they put it in parentheses, sometimes they don't, but 3x is the angle. Okay, so sine of 3x, right? So if we were doing, again, go back to last semester, if we were doing derivative of this, it would be a chain rule, right? We'd find the derivative of sine, and then we'd find the derivative of 3x, chain that on, right? So that kind of gives you an idea, hey, it's probably going to be a U substitution problem if we're doing the antiderivative. Okay, so the key here is finding what the argument is. What is U going to be? Okay, so remember, the argument is the innermost parts. The innermost parts. So what is the innermost part? One second, guys. One second. Let me take this. Okay, so what is the argument going to be on this question? What is the argument going to be for on this? The innermost part is 3x. Yep. All right. Okay. So that's going to be our U. Okay. That's step 2. Or step 2 is find U. Step 3 is, okay, derivative of that. If we identify U, the derivative is going to be 3 and always tack on a dx. Remember, always tack on a dx when you find derivative du. Okay. Step 4, solve for dx. Divide by 3. Okay. So we divide by 3. So I have dx equals 1/3 du. Okay. Check. Step 5, substitute du. Substitute in u for the argument and dx. I should put dx up there. So what is that going to look like now? Well, we still have sine because sine isn't changed, right? But u is now 3x. So instead of 3x, I'm just going to put u. And dx now is 1/3 du. So that's going to go in its place over here. So times 1/3 du. Okay, that's step 5. Sub in it. Okay. Oops, why did I put X? I shouldn't have put X. Should be just sine. Just sine. Sine of U. U is the angle now. There's no more X's. It's only U's, right? That's how I know I did it correctly. There's no more other letters. There's no other variables. It's just one variable, and that's U. Okay. I have a 1/3. So what I'm going to do with the 1/3 is I'm going to move it out here. That's step. I forgot about that. I forgot to write that step up there. That's the step between 5 and 6. Is any multipliers, move them out to the front. Okay. Now I find the antiderivative of sine u du. That's a lot easier than at the beginning. Sine of u, well, the antiderivative of sine, what is the antiderivative of sine? Negative cosine, yeah. So I have 1/3. I'm going to put the negative out in front of the 1/3. Cosine of u, and then plus c, right? No more du because that disappears when you find the antiderivative. Last step, sub everything back in. So instead of u, so put in what u was. U was cosine now 3x plus c. Okay. So this guy right here is the antiderivative of this guy up here. They're antiderivatives, right? If I wanted to find the derivative of this, I would get that guy there. You could do it. We know how to find derivatives of this. We know how to find derivatives now, right? So that's how you check. That's another way of checking. Yesterday, I told you guys, one way of checking is the powers, checking the powers, right? If we find antiderivative, we should go up in power. Well, another way to check is if I find the derivative of this guy, do I end up with my original? If the answer is yes, then you did it right. All right. Okay, so let's look at this guy here. Okay, so we have a natural log of x over x. Okay. There's still an argument. We still do our steps. Doesn't matter if it's a natural log of a trig function, a regular polynomial, like we started with yesterday, like these polynomials that we did yesterday, right? It doesn't matter. We continue with our steps. But here it might be a little, I don't want to say difficult, but it might be a little tricky to find out what the argument is. So what is the argument going to be here? What do you think the argument's going to be here? We have two options. You have two options for the argument. What do you think those two options are? Well, what's the obvious option? What's the obvious option for the argument? Yeah, natural log of x, right? That's kind of sticking out, right? That's kind of sticking out there. Natural log of x seems like it could be an option, right? Well, there's another option too. You can't really see it, or you might see it. I don't know, but it might help if you did this. If I rewrite it like that. When you rewrite it like that, you see that, oh, I have this guy too. Not only do I have this guy, but I have 1 over x, x to the negative 1. That could be, right? Here's how you tell. So step 1 is identifying u, right? We're kind of stuck on that. What is step 2? find the derivative of u, right? So let's go back to some of these guys from yesterday. Nope. Nope. Yes, here. When we found u, right? We said it was x to the third plus 2, right? And then we found the derivative, which is 3x squared. When we plugged in dx, what happened to the other stuff that was in there? When we plugged in u and du here and here, or u and dx, this step right here, what happened to the other stuff that was in there, that was in the equation or in the function? What happened at this step here? Canceled out, right? They canceled out. Otherwise, I would be stuck with some x's here, right? I can't do this process unless I have all u's. If I have all u's, one letter, I can do that, right? So let's go back to we want stuff to cancel out. So the issue here is I have two functions and they both have x, right? So when I plug them in, when I plug in my dx, I want it to cancel out with what's there. So natural log of x and 1 over x are very much related. How are they related? What's their relationship between natural log of x and 1 over x? How are those related? Going back to last semester. The derivative of natural log of x is 1 over x, right? So if I make one my u and one my du, they're essentially going to be kind of the same thing, right? So another way to do it is just kind of go with it. Go with it. Let's try something. If it doesn't work, we'll back it up and we'll try it again. Okay? Again, this is probably the hardest part about U substitution. Once you get your U, it's off to the races. It's just the same steps every time, right? But I told you guys yesterday, this is the hardest part about U substitution. It's finding out what is U going to be, because sometimes they're not as they don't appear like this guy does, easy, right? You're like, oh, I got that one. This guy here, oh, I got that one, 5x plus 4, right? Sometimes they're hidden a little bit. So that's the hardest part sometimes. Once you can find your U, then it kind of repeats. So let's try this. So what I'm going to do here, so give me 1 second. When I find my U though, can I do this? My question is, when I find my U, can I do that? Can I have my U be natural log of x? So if that's the case, what would my du be? Go on with the next steps. What would my du be? Go to the next step. The only way we're going to know if this works or not is by trying it. So if you say that's my u, what would your du be? Okay, sub it back in. What do you get? If we need to erase it, we'll erase it afterwards. But this is part of the process. Is sometimes you get it wrong, sometimes you get it right. So what we're trying to do is figure out what in the world would work for this guy. Okay. So what would my du be if I chose u as natural log of x? What would my du be? Dx, right? And then I solve for dx, right? That's my next step. So 1 over x, or instead of dividing by 1 over x, it's the same as multiplying by x over 1, right? So I get dx equals x times du, right? So we said this is going to be our u. This is going to be our dx. Let's plug it back in. Okay. So when I plug it back in, I get 1 over x. I still have 1 over x. That's still there, right? Natural log turns into what? U. Dx turns into x du. Okay. I see I have some x's and u's. Do the x's take care of themselves? What happens when I multiply this guy and this guy? They make 1, right? They simplify, which is what I wanted, right? So now what I have left with is u du. Okay. U is just like x. So add 1 power, divide by the new power. Last step, sub in what I need to. Sub in what it was from the very beginning. So u was natural log of x squared plus c. So that's kind of the key there. We want it to match. What I mean by match is I want, if I pick whatever I pick for my u, when I find the derivative of it, I want that to match what's still in there. Because when I divide by it, guess what? It's going to cancel out. That's what I want to do. Okay? Because I could have done this. I could have said the other option was this. Don't write this down, but the other option was saying this could be my u, right? But then the derivative of that would have been x to the negative 2, negative x to the negative 2. So it would have been this. When I plug this back in to here, it would have canceled out something, but it would have left an x. I don't want to leave an x. I want x's to go away completely. So that's why this guy over here doesn't work. That's why you chose natural log. Again, sometimes you make the mistake of choosing the wrong function as the argument. It doesn't work. So by step 5, when you sub it back in, you're like, nah, it doesn't work. Okay, start over. Pick a new u. Okay, pick a new u. You can always do that. Okay, you can always start over. All right, so what I want you to do now is I want you to try 4e on your own. Do 4e. We're back to polynomials now. Okay, 4e on your own. We'll go over it in about 3 to 5 minutes, something like that. Okay, so if you're still working on it, keep working. So I said my U was, so I rewrote it. First thing I did was rewrite it. 3 times 2x plus 5 to the negative 1/4 power. Negative because it's underneath, it's in the denominator, and 1/4 because it's the 4th root. So hopefully it was kind of not obvious, but hopefully it was clear that 2x plus 5 was going to be your U. That's the inside. So once you get that, go from there. So the derivative is 2 dx. Solve for dx. I plugged everything back in now. So I only have u's. There's no more x's, right? Which is good. I can continue on my steps if there's no more x's. So I have a 3 here and a 1/2 here. So what I'm going to do with both of those guys is multiply them and put them outside. So I'll have a 3 over 2 u to the negative 1/4 du. Okay. Now I'll go through my, now I'll use the power rule. Now I can use the regular power rule. So I add 1 power. So that's 3/4. Divide by 3/4. That'll make 4/3 out here. But I already have the 3/2 out here that I need to multiply, right? So I got to multiply by 3 over 2. Plus C. So when I do that, the 3's cancel out, the 2 will cancel out and make a 2. So all you're really left with is just 2 out in front. So 2, and then 2x plus 5 to the 3/4 plus C. Done. Okay. All right. Try this one. Try F. Okay. So 1 minus 4x cubed, that's my u. The derivative is negative 12x squared. Solve for dx, 1 over negative 12x squared du equals dx. So then I plugged in u, and I plugged in dx. When I did, the x squareds canceled out, which I wanted them to. I wanted the x squareds to cancel out. So, and then that left negative 1/12. Negative 1/12 I can deal with. But if it had any x's with it, I couldn't deal with that. Okay. So some of you might be asking the question, like, what happens if I do this and there's still an x left over? Let's say I cancel out stuff and there's still an x left over here, or there's still an x left over here. What do I do? The answer is you don't have to worry about that in this class. This class you won't. Everything will simplify. If something happens like that, look over your earlier steps, because you probably did something wrong there. You won't have that. Is it possible? Yeah, it's possible, but it's not in this class. It's a calculus 2. If you take it in, this is the equivalent of taking calculus 1 at like Fresno State or City College or wherever. Calculus 2 is the next class. That's where you tackle that. There's a way of doing it, but I'm not going to show you because you don't need to worry about it in this class. Okay. So if you do get an x left over here or somewhere in there, go look over your previous steps, because you probably did something wrong, or you chose the wrong u or something like that. Okay. All right. Okay. Let's jump. We're going to come back to these guys, but I want to jump to, let's go to J. Let's look at J. We'll come back to the others, but I want to look at as many different options as possible. We looked at a natural log. We've already looked at a trig, right? I want to look at another trig, because trig can kind of be a little tricky sometimes. They're so simplistic that sometimes it can be confusing. Okay, so here we go. First thing I would do is rewrite it. Right? I don't like that they have the cubed up there. I don't like it when they do that in trig because it's hard to work with in me. I don't. Maybe I just have um, a algebra brain, but it's just I hate that. So what I do first thing I do is I change it. That 3 means it's just cubed and then times cosine of x, right? If it doesn't bug you, you can leave it. If you know, I know what it means, but I just don't like the way they do that. Okay, it makes more sense to me now. Now it means whatever I get for sine, I cube it, then multiply times cosine. Here's the question now. What's my u? It's sine times cosine, sine cubed of so I can't use the power rule, right? What's my u going to be? Again, I have 2 options. What are my 2 options that my u could be? What are my 2 options that u could be? Mm-hmm. It could be sine of x or it could be cosine of x. Yeah, I know sine of x has the parentheses right there, but don't let that fool you. Okay? This is how you determine it. When we pick a u, what's the next step we're going to do immediately after picking a u? Find the derivative, right? And the reason we find the derivative is because when we plug back in, we want it to cancel out. So I know u's already in there, but when I find du, I want to make sure it's also in there as well so that it'll cancel out. So let's say I pick sine as my u. Let's say I pick sine as my u. What would my du be? Cosine, right? So if I pick u as sine, I'm not saying this is correct. I'm just go with it. The easiest way to do these things sometimes when it's not clear is go with it. And if you run into a brick wall somewhere, then you're like, okay, obviously I did something wrong. Let me try a different u. What would my du be? Cosine of x dx, right? The next step, divide, right? Divide by cosine of x, divide by cosine of x. So dx equals 1 over cosine of x dx. So here's my u, here's my dx. When I plug those guys in, is it going to get rid of all of the x's? All of the cosine and sine are okay. I can have cosine and sine. Those are okay. But I can't have like this guy over here. The first one we started with, right? I had sine here. When I plugged in u, I had sine here, right? That's okay. Sine is okay. I just can't have any x's here with the u's. I can't mix x's and u's. So let's try plugging it back in and seeing what we get. So when I plug it back in, what am I going to get? U cubed times cosine of x. Cosine's got to stay because I didn't do anything with cosine. Okay. Now I'm going to plug in my dx. Okay. Instead of dx, I'm plugging in 1 over cosine of x d. Oops, it should be du. Will they cancel out? So I'm left with u to the third du. No more x's. Okay. I kind of want to do the problem again, but I want to do it wrong to show you how you know you made a mistake. So let's finish it out and then I'll do it again, but I'll do it wrong. I'll pick the wrong u and I'll show you what you would see, because it's important to see, to understand what happens when you make a mistake. How do you know you make a mistake, right? If you don't know you make a mistake, then you keep thinking you're doing it right, and then when really you're not doing it right. So let's finish this out first. So I have I have u to the fourth divided by 4 plus c. So let me move it back in. Done. Okay, so you don't have to write this part down. I just want to show you what happens if you do it wrong. What are you supposed to look for if you do it wrong? So let's do the problem again. Okay. So what if I choose cosine instead? Let's go down this rabbit hole. If I choose cosine as my x, as my u, what would my du be? Negative sign, which is there, right? That's in there. Okay. Dx divide by negative sign du equals dx. Okay, plug it back in. Okay. So sine is still there, right? Sine cubed, sine of x cubed is still there. Cosine becomes u, and then dx is 1 over negative sine of x du. What's going to happen now? Am I going to have an issue, or could I have done it this way too? So yeah, so you cancel this guy out, right? This guy with this guy over here, but there's not. If there was only one of them, there's not one of them. How many is there? 3. So this would move to 2, right? So you're right. I'd get a negative 1 there, so I can move the negative 1 to the front, but I would have this. And this is how I know it's a no-no, because I have an x and a u combined. I can't have that, right? In order for me to do the antiderivative, to go on to do the last steps, I can't have an x and a u. So if this guy was first power, so if you had sine times cosine, so if the question was written like this, you could do it either way. You could pick sine as your u, or you could pick cosine as your u, and you could do it that way, right? That would work. But because it's cubed, we only have one option. We have to pick sine. Okay. Okay, let's do one more. Let's do the one right underneath it. Let's pick an e of x. So polynomials, roots, trig, natural logs, and e of x's. Those are the ones you're going to find. Okay. So I have 2 options. So let me rewrite it. First thing I like to do is rewrite it to see what options that I have. Well, I have 2 options. I have regular e to the x, and then I have e to the x plus 1. Which option should I choose as my u? again, if you get it wrong the first time, you just go back and start over there's only two options. So if you're wrong the first time, you're going to get it right the second time. Okay. So which one do you think? And they're pretty close. One's e to the x and one's 1 over e to the x plus 1. So they're very similar. So which one do you think I should pick? You can rewrite it like this. If you want to rewrite it like this, you can. You don't have to, but you can say e to the x plus 1 to the negative 1. You can do that too. Which one would I pick as a u and which one would I pick as a du? Mm-hmm. So say that one more time. Is it the u? Let's try it. There's only two options. So if we get it wrong, we know what the answer is. So let's try it. So let's see, e to the u is e to the x plus 1. Okay. Du. What would du be? Close. Just e to the x, yeah. Because the plus 1, if I find the derivative of 1, it's just 0. Mm-hmm. But yeah, dx, right? Divide. Okay. Let's plug everything back in. So I have e to the x, that original e to the x that I didn't highlight in green, that's still there. The stuff in the green is now going to become u to the negative 1. And then for dx, oops, not green, yellow. I'm going to plug in this guy here. Did I make the right choice? Yes, I did, because these guys will go away. And you're left with, good, don't worry x's. I have just u's. Okay, so find antiderivative. Add 1 to the power, divide by the new power. Is there going to be a problem? Yeah, there's going to be a problem, right? I'm going to get u to the 0 over 0. Can't be anything, can't be, u to the 0 is okay. But if I divide by 0, that's a no-no. So what do I do? Yeah. There you go. The derivative of this guy should be written somewhere in your notes, but if it's not, highlight it, underline it. The derivative of this guy, or the antiderivative of this guy, is natural log of x plus c. Okay, it's written somewhere in your notes because I remember we've talked about this before, but which is the same thing as, right, the natural log of x plus c, right? We use the absolute value bars around the x because I can't take a natural log of a negative number. Doesn't work. If you don't believe me, ask your calculator. Natural log, try natural log of any negative number, it will give you an answer. It'll say error. Okay. So we're going to use that. So we're going to say it's the natural log of u plus c. Plug u back in.